Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to the Natural Sciences lesson. My name is Tawile Teben, and this program is proudly brought to you by the Howden Department of Education. Remember, grade 8, this term we are looking into space. We are doing planet, Earth, and beyond. And this knowledge area contributes about 32 marks in your final paper. And we are looking into space today, and our subtopic is telescopes. We want to see how we view the bodies in the space. First of all, we're going to look at our lesson objectives. We need to set a goal for ourselves. By the end of this lesson, we should all be able to state how space was viewed. Remember, space was viewed in the early days, in the 16th. All right? But how was it viewed? And then we're also going to name types of telescopes. We're also going to explain how a telescope works. We get all this from the CAPS document, page 55. Pre-knowledge. This is the foundation that you already have. You have already laid a foundation. Remember when you were in grade 6. What did you do in grade 6? You did the solar system and systems for looking into space. And then you also did the systems to explore the moon and the Mars. Systems for looking into space. This is the topic we are doing today. Therefore, we have already laid a foundation. Today, let's just build on. You already know this topic. It's going to be interesting. And then our baseline activity is going to make us remember what we've done in the past. Remember this term, our topic is basing on planet Earth and beyond. We are looking into space. All right. And then question number 1 says, list 8 planets. Remember the 8 planets that we've already done in the previous lessons. And then question number 2 says, what is the name of our galaxy? You are going to name our galaxy. And then question number 3, name the star that is closest to the Earth other than the Sun. I'll give you 3 minutes to answer the questions. Let's start answering the questions, grade 8. Hope you are done answering the questions, grade 8. Let's look at the questions again. Question number 1 says, list 8 planets. 2, what is the name of our galaxy? And then question number 3, name the star that is closest to the Earth other than the Sun. Let's check our solutions. Remember, when we are listing the planets, remember what I said. What did I say? I said, in order for you to grasp this, first, just say my very educated mother just show us nightingale. Nightingale. All right. My very educated mother just show us nightingale. This is Mercury. We are naming 8 planets. This is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are 8. So you can say my, which is Mercury, very Venus, educated Earth, then mother, refer that to Mars, and then just to Jupiter, then show that is Saturn, then us, Uranium, then Nightingale, Neptune. All right. And then question number 2. Let's check question number 2. It said, what is the name of our galaxy? The name of our galaxy is what? Grade 8. Remember what we did in the past. We said the name of our galaxy is the Milky Way. This is what we have already done. Remember what we did last time. And then question number 3. Let's check question number 3. It says, name the star that is closest to the Earth other than the Sun. Which star is closest to the Earth other than the Sun? Remember, the Sun is a star. And then the other star that is closest to the Earth other than the star is what? It is Alpha Centauri. Okay. These are our answers for the baseline activity. You can just take a picture of your answers and send us on 064 748 8913. Our WhatsApp number again, 064 748 8913. Don't call, don't make a voice note, just text us. All right. We've got an amazing team behind the scenes who are eager to help you. Let's continue. We are going to look at terminology. Terms are very important, grade 8. Why am I saying terms are very important? In your exams, you come across the terms. You need to define terms. As from now up to grade 12, you'll be defining terms. Okay? When you are defining a term will carry about 2 marks. These are just marks that you are given. Right? Therefore, pay particular attention in the terms that we are going to define. In each and every lesson, we'll be defining terms. Make sure you grasp those. It will help us to understand our lesson, and it will help you during your exams to define these terms. All right, we've got the first term here, telescope. What is a telescope? It's an optical instrument that makes distant objects appear near. The distant objects appear closer and they become clearer. That's why we are able to see objects in space. All right, that's why we now know the galaxies that we have. All right, that's why we also know the what? The planets, which we cannot see using our naked eyes, but with telescopes, we can see a lot of things, a lot of bodies on space. And then we've got astronomy. What is astronomy? This is the study of bodies in space. And then what is an astronomer? All right. These are people who study the bodies in space. This is an astronomer. And then early viewing of space. Remember, technology is changing. All right, we are developing. But in the olden days, they were able to view space. We call this early viewing of space. They invented instruments to look into space. And now what are we doing? We are using those very instruments, but we are developing on them. Right? We are making them to work better for us. All right. It was in 1608 that a Dutch eyeglass maker discovered that by looking through two small lenses held in front of one another, a distant object appeared to be closer. A distant object will appear to be closer. He had invented the first telescope. All right. This is a Dutch eyeglass maker. And then when he took two lenses and put one in front of the other and viewed objects, he saw objects at a further distance appearing larger and nearer and even clearer, because some objects from a distance we can't see with our naked eyes, but if you've got these lenses, you can see them. And he's the person who discovered or invented the first telescope. All right, and now there are a lot of telescopes, but we got the idea from the first Dutch eyeglass maker who invented the first telescope. Interesting, isn't it? And then just a year later, a famous Italian scientist called Galileo Galilei assembled a telescope that made objects 30 times closer. You can imagine a telescope making objects appear to be 30 times closer to us. This is interesting. I love this. And then when he looked at the moon, he was amazed at the details he could see, because he could see a lot of things that we cannot see using our naked eyes. Therefore, the telescopes help us to see things that we cannot see, and it makes things seem to be closer and even clearer. All right. And then when he looked at the moon, he was really amazed at what he could see, because he could see a lot of things that were not seen with a naked eye. For the first time, he could see craters, mountains, and valleys. He also saw the 4 largest moons orbiting Jupiter, and he saw dark spots in the sun. Remember the structure of the sun, grade 8. Okay. We've got the structure of the sun, which is a ball of what? Of glowing gas, because a sun is a medium-sized star. And then it has got the inner core. And the inner core is where it is very hot. Okay. And that's where the fusion is taking place. And then we've got sunspots. These are the cooler parts. You will see dark spots on the sun. These are the sun spots. And then we also have the what? The solar flares. All right. These are the explosions which are happening. Then we call them the solar flares. This was very interesting. And then when Galileo looked at the Milky Way, his telescope did not seem to bring stars closer, because they are too far away. The stars are far away. And then, but he looked at the spaces between the stars. Remember, there are spaces in between the stars. And he was very surprised to see many stars appear. The number of visible stars had seemed to increase 1,000 times by the invention of the telescope. When the telescope was invented, a lot of stars were seen. Okay. It seems as if the stars had increased by 1,000 times. And then from this time onwards, steady improvements in the quality of telescopes were allowed. They had allowed astronomers to see more and more detail in space. New types of telescopes have been invented, and they had added to our knowledge of the universe. Remember, before telescopes were invented, it was very difficult to see details in space. But when they were invented, we saw a lot of things in our universe. We were able to study our universe in depth. All right. These are very important. The telescopes are very important when we're looking into space. They help us a lot. And then telescope work very much like a what? Like a human eye. Okay, because you could see using a telescope. But the difference is that the telescopes bring things closer and things will appear clearer. Okay, the objects are going to appear clearer. Like the eye, its main job is to collect light given off from a distant object and focus that light so that we can see the object. Remember when we were doing visible light grade 8, what did we see? How did we describe light? Remember white light. If white light strikes an object, what happens? The object will reflect the light back to our eyes. And then when light gets into our eyes, we can see the color of the object that has been reflected. Do you get that? And then the colors that we cannot see, it means they've been absorbed by the surface where it strikes. Okay? White light will strike an object and then the reflected ray will come to our eyes and then we can be able to see which color is being reflected. Why? Because the light has to enter our eyes. Therefore, the telescope works the same way as the eye because it will see the light that is being reflected to it. That understood? Okay, that's good. And then we've got an optical telescope. An optical telescope, these are telescopes that you can look through. It's a simple optical telescope. It consists of a what? A long tube and two lenses. For example, we've got a picture here of an optical telescope. All right. When you put your eye here, this is an eyepiece. Okay. And then small lens magnifies and focuses light for your eyes. And then we've got a light that focuses here. You see this place. And then we've got a large lens that gathers and bends light. How can light be bent? All right, if we're talking about light, remember light will travel in straight lines. But once it hits a glass object, what's going to happen? Or even water or even other objects, light will refract. For example, here we're talking about the lens. The lens is glass. Then light is going to refract. If I say light refracts, it means light will bend. All right, light will bend. And then this is the light that has been reflected and it enters the what? The telescope. Therefore, the telescope works exactly like a what? Like an eye. All right, this is a optical telescope. It enables us to see things that we could not see using our naked eyes, and we could see things that are further away from us. For example, we could study our universe simple now because of this telescope, because it brings things closer and it makes objects look clear. Do you get it? Good. Let's move on. The lens at the end of the tube nearest the object is called the what? It is called the objective lens. And the lens nearest to your eye is called the eyepiece lens. All right. This is the eyepiece lens here that is next to your eye, where you put your eye to see the objects that are further away. And then this object here is called a what? An objective lens. And then when light enters the telescope, the light is bent or refracted. We said if the light enters a telescope, remember light travels in straight lines, and then once it hits the glass, that is the lens, what's going to happen is going to refract. That is bending by the objective lens so that it focuses that light or image at a point. The eyepiece lens will magnify. It will make things appear bigger. It's going to magnify the image, making the object look bigger and clearer. Because the light is bent, we say this telescope works by refraction. Remember the term refraction. If we're talking about refraction, we're talking about bending of light. All right. Remember, light travels in straight lines, but once it hits the lens, it will refract. Okay? It will bend. Let's move on. Grade 8. We are still talking about telescopes. Beta optical telescopes have larger lenses. The lenses are larger. Even beta optical telescopes use mirrors as much lighter than glass lenses. They are also more powerful as they can collect more starlight. When mirrors are used, the light is reflected up and down the tube. Okay, this increases the focal length of the telescope and allows it to see objects that are further away because the light is reflected. We say this telescope works by reflection. When we are talking about reflection, grade 8, we are talking about this. For example, let's say this is our surface, and then we've got an incident ray coming in here. This is white light. Then it will strike this object. And then here, remember, we've got our normal, which is an imaginary line that is 90 degrees to the what? To the surface. And then we've got a what? A reflected ray that will go out here. If the incident ray is striking the surface, we call this the incoming ray. And then this one is outgoing. This is incident ray. Then this is our normal. Our normal is an imaginary line. And then we've got a what? A reflected ray. Okay. And then here we are talking about a reflected ray. What does it mean? If white light strikes an object or a surface, then we've got a reflected ray that will come into our eyes. Therefore, when we're doing visible light, we're able to see the color of the object. It is determined by the reflected ray. Why? That is the light that is going to enter our eyes. And then the light that we cannot see, for example, if we're talking about color, the other colors will be absorbed by an object. This surface is going to absorb the other colors that are not reflected to our eyes. But if white light strikes an surface and we see white, it means all the colors in the visible spectrum are reflected to our eyes. But if we can only see yellow, it means only yellow is being reflected to our eyes, because it should enter our eyes to the retina, then it will be transported through the what? The optic nerve to the brain. Then the brain is going to interpret the color that we are seeing. Okay, it works the same. Therefore, our telescopes are working just the same as our eyes. And then South Africa is one of the world's largest optical telescope. We call this what? We call this SALT. This is the Southern African Large Telescope, and we normally call it SALT. It is the largest single optical telescope in the Southern Hemisphere. It is the largest. It has a reflecting telescope. Where is it? It is here in our country. It is in Northern Cape. SALT is situated near Sutherland in the Karoo in the Northern Cape. The site was chosen for its dark, clear skies and good weather conditions. This is a dry part of the country, so the air has low humidity. All right. Remember, Northern Cape is a semi-desert. It's a desert area. Okay. Therefore, it is dry. It's a dry place, and the skies are dark. Why are we saying the skies are dark? It is not polluted by light. It is not like the city centers, like in our city here in Houghton. There are a lot of lights. Long back, remember, these telescopes were situated near the cities, but the lights were disturbing because you can view clearly from a place that is very dark. All right? For example, in Northern Cape, the province is not yet polluted. Therefore, that's why we've got SALT there, our largest telescope in the southern hemisphere, situated there, because it is very easy to view space from them. And the other telescopes are being put there. Why? It is because of the weather conditions. The weather there is permitting, because it is normally dry, okay? And it is not as windy, and it doesn't rain a lot. Therefore, it allows us to view from there, and we get good results from that place. And then SALT is a very powerful telescope. Remember, we've said it is the largest in the southern hemisphere. Okay, and it is very powerful. We can view our universe from them. It can detect light from faint, very faint or distant objects in the universe, 1 billion times too faint to be seen with the naked eye. You can see how powerful it is, because we are saying we can view objects from the universe 1 billion times too faint to be seen with the naked eye. You can imagine how powerful SALT is. Okay. And it helps us to study the universe better, because we can see a lot of objects that we couldn't see using our naked eyes. And then let's move on. And then the telescope in space. We have even invented the telescopes in space. Okay, and we have sent them in space so that they can take videos, they can take pictures, and then we start our universe better. Okay, even with the best optical telescope, the Earth's atmosphere sometimes stops us from getting the best images of distant bodies in space. The atmosphere can distort or bend the light coming from stars. This is the atmosphere. And there is dust and water vapor in the atmosphere. So scientists have sent telescopes into space on rockets, where they now work as satellites. Okay. And then satellites take pictures of bodies in space without looking through the what? The Earth atmosphere. The atmosphere can disturb, all right? But if we send satellites to space, they can take better pictures of the universe for us, because they are not disturbed by the weather conditions. All right. And they are not disturbed by the artificial light that is our light. For example, electricity, solar, all the light that can disturb. There is no pollution at all. Okay. And then these pictures are sent back to Earth. They go into space, so they are sent into space, and then the pictures are taken, and these pictures are sent back to Earth. The results have been spectacular and have given scientists a different view of the universe, because now we could see what we couldn't see earlier. All right. And then we have views of distant planets that we couldn't have seen from Earth. It is because of these satellites that have been sent into space. We can see details of the universe that could be fuzz blobs if we have seen them from Earth. We couldn't see them clearly, but now we could see them clearly because they are far away from us and they appear to be very small and faint. But using these telescopes, They help us a lot because we are now getting what? A clearer picture. Okay. And then Hubble telescope. The most famous of the space telescope is the Hubble Space Telescope. It was the first major telescope to be sent into space in the 1990s. You see the development that is going on. The first telescope was invented by a Dutch in 1608, but now in 1990, the first major telescope that was sent into space, it was sent in 1990, and this is a Hubble Space Telescope. It has an unobstructed view of the universe. It can take nearly 600,000 photographs of bodies in space and still sending fantastic pictures back to Earth. You see how many photographs it can take, how many pictures it can take for us and send back to Earth. 600,000 is quite a lot. Therefore, it makes us to be more knowledgeable than before. It makes our studies easier. Hubble telescope has to be serviced by what? By astronauts taken into space on a what? On a shuttle. And then we've got radio telescopes. Optical telescopes are not the only kind of what? Of telescope. Scientists have discovered that all bodies in space like stars, planets, black holes, and even galaxies give out radio waves, which we cannot see with our naked eyes. We need to use a different kind of telescope to find and record the radio waves. We use radio telescopes to do this. Okay. Therefore, the radio telescopes are very important. Radio telescopes do not have lenses or mirrors, and we do not look through them. There are many different designs to collect different types of radio waves, but these designs usually have a metal ball or dish to receive the radio waves. Scientists make pictures from the radio waves, but in order to work well, radio telescopes need to be far away from cell phone and radio networks. Remember what you even use at home. We've got satellite dishes, all right, that collect these waves. And then further on radio telescopes, the radio telescope on its own can only collect a small amount of information, but a group of radio telescopes working together is called a what? It is called an array of telescopes. If they work together, then we get a better or a quality information. Okay. And then we've got KAT, that is Cat7, and MERCAT and SKA. These are radio telescopes. South Africa has a number of large radio telescopes. The first was built in the 1960s, where at the Hartbeespoort in Gauteng, but more recently the Cat7 array was built in the Karoo. That is, Cat7 is part of the MERCAT. A larger array is still being built. If we are talking about an array, we are talking about a man or a group of what? Of telescopes. They work together. Why? Because we need quality. All right. We get quality when they are working together. When finished, it will be the largest and most sensitive radio telescope in the southern hemisphere. Unit SKA is completed. Okay. For example, if we are saying this is the largest, would be the largest in the southern hemisphere, it's like our own salt. It is the largest in the southern hemisphere, and we've got it here in the northern Cape. And why northern Cape? It is because of the weather conditions and even the pollution. The sky is not polluted. The place is not polluted. The skies are still dark. They are not polluted by light. Right. Therefore, we'll get a better view of the what? We'll get a better view of the bodies in the universe. There is no disturbance. Even the air is not humid, it is dry. Okay? And the winds then, it's not as windy as in other parts of the country. Okay, therefore the conditions in the Northern Cape are good. That's why we are still building radio telescopes there. Okay. And then we've got GAT7, and MeerGAT, and SKA. SK is the what? This is the square kilometer array. Remember what we said about an array. If we're talking about an array, we're talking about a group of these telescopes working together. It is an array. This is a huge radio telescope with thousands of individual telescopes. It will be the most powerful telescope ever built. It will be able to see the furthest parts of the universe, right? And to see back to the time before the first stars and galaxies formed. Do you see this picture? These are a lot of individual telescopes, but together we call them an array. Okay, and they give us the radio waves. Okay, let's move on. And then we've got good conditions for looking into space. Remember, when we're looking into space, we don't want disturbances. We want the air to be dry. We don't want a windy place. We don't want water vapor. We want a place that is dry. We don't want a place that has got a high humidity. All right. The main task of optical telescope is to collect light from distant objects. Remember, they collect light from distant objects just like an eye. We can see things because light is being reflected to our eyes. That's why we see them. If we close our eyes and don't allow light to get in, we only see dark. We only see black. All right? Because there is no light that is being reflected to our eyes. You get that? All right. Therefore, telescopes work exactly like our eyes. Anything that stops the light from getting to the telescopes will mean the image received will be poor. Okay, the image will be very poor. The best conditions for large optical telescopes are the weather must usually be clear. There shouldn't be any clouds. The weather should be clear, no clouds. And then the air above the telescope must be still, not moving. It mustn't be a windy place. It mustn't be a windy time. And the air should be very dry. The amount of water in the air, that is the humidity, must be very low. That's why we need a place that is a semi-desert like the Northern Cape, where it is dry and it is not all that windy and the skies are dark. All right, there is no pollution because of lights. Like near the cities, there's a lot of pollution because there are a lot of lights that will disturb. But in the Karoo, there's no disturbance. That's why we are seeing the images of the objects in the universe very clear. Okay. And then we've got also good conditions for looking into space. The sky must be very dark with no light pollution from street lights or city lights. Okay. The telescope should be at a high altitude above sea level. This is because Earth's atmosphere distorts or bends the light from stars. We don't want the light from stars to be bent. We don't want light to be refracted. We want it to come and then we collect it so that we can see what is in our universe. This is why large optical telescopes are built in places where they can receive the best images possible. Often these places are in desert or on mountains. We can see better when it is a desert area because usually it will be very dry and on top of mountains. Okay, these are good places for putting our telescopes. Some famous places in the world for telescopes are what? Mauna Kea in Hawaii, that is 42,767 meters high. A volcano on Canary Islands that is 2,133 meters high, and Atacama Desert that is in northern Chile. And then the good conditions in South Africa. South Africa has many locations where conditions for observing the sky are very excellent. Remember, we've got desert areas, okay? Many parts of the country have fine weather and still dry air and dark skies. Our skies are not yet polluted by the lights, okay? And the air is dry, and most parts of the country, the air is still. The place is not windy. Some time ago, a number of telescopes were erected in or near the cities. But after 1972, the Karoo region of the Northern Cape was chosen to be the astronomical center. It was chosen to be the astronomical center. This is why SALT, CAT7, MERCAT, and SKA will all be located. A world-famous center for astronomical studies. Why? It is because of the good conditions. It is because it is a semi-desert, and the air is dry, and the air is also still. Therefore, there is no pollution as well from the city lights. Okay, the skies are dark. And then they give us a good or clear image of what we are viewing in space, of the bodies that are in space. All right, we are going to write our activity. Question number 1 says, people who study the bodies in space are called what? And then question number 2, a group of stars that form a pattern is called a what? I'll give you 2 minutes to answer the question. Let's start answering the questions. All right, grade 8, hope you have answered the question. Question number 1 says, people who study the bodies in space are called what? And then question number 2, a group of stars that form a pattern is called a what? Let's look at our solution. These are astronomers, and then a group of stars that form a pattern in the sky is called a what? A constellation. All right. Let's summarize our lesson, grade 8. Telescopes allow people to see much more detail in the sky. Why? It is because telescopes have got lenses. They bring things closer. They make objects appear to be larger. That's why we can view them from space. That's why we can have a picture of what is in space. All right. Therefore, they were invented by a Dutch astronomer they were invented by a Dutch eyeglass maker in 1608. How? He took two lenses and put one in front of the other, and he saw distant objects appear to be closer and clearer. Right, that's when it started. But now we are building on what was already invented. We're making it to be user-friendly. Okay, like our own salt in the Karoo. We can see the images in the universe. We can have quite good knowledge of what is happening in space. We can study our universe better because of these telescopes. And then telescopes gather light, form an image of a distant body and magnify the image. If we're saying telescopes gather light, form an image from a distant body and magnify the image, what are we meaning? Telescopes will work like a what? Like an eye. They work like an eye. They gather the light. How? If white light, for example, if it strikes an object, what will happen? Then it will be reflected to our eyes. That's why we are able to see what we are seeing because of that. Same applies to objects. They also need light. For example, if we're studying the universe, light from the stars, the light is going to enter a telescope. Then it will process it and we can see those distant objects become larger. Why are they become larger? It is because we are magnifying them and they become very clear because now they are closer to us. We are able to see the details in space. We are able to tell what is what in space, how things are arranged in space. This is interesting, isn't it? Good. And then optical telescopes. Optical telescopes use lenses or even mirrors. Okay. These are optical telescopes. They use lenses or even mirrors. They focus the light by refraction, that is by lenses, or reflection, that is mirrors. If we are talking about refraction, what are we talking about? We are talking about the bending of light. All right. Remember when we did visible light grade 8, we said white light is going to what? To strike an object. All right. For example, if it strikes a glass prism or even a water droplet, what will happen? Then the colors of the visible spectrum will be visible. In this case, refraction is also working because light travels in straight lines, and then when it hits a what? A lens, it bends. That is refraction. Okay. Allowing us to see what is happening in space. This is a type of a telescope that is using what? Refraction. Okay, you get it? And then we've got reflection, we've got mirrors. If we're talking about reflection, let's say white light come in with a what? Incident ray. This is an incident ray, this is incoming light. And then it strikes a surface and it is reflected. All right? That's why we are talking about mirrors. If it is reflected back to our eyes, then we are able to see that light. We're able to detect what it is. Even the optical telescope use lenses or even mirrors. Okay, it works like an eye. Then we are able to detect what is happening. All right, that's why we are able to study the bodies in space. Now it's even easier than long back when the first telescope was invented in 1608 by a Dutch eyeglass maker. And then a well-known optical telescope, we've got SALT. Okay, SALT, this is the Southern African largest telescope, and the Hubble Space Telescope. All right, and where are these situated in our country? They are situated in the Northern Cape province, and to be specific, the area is the Karoo. Okay, why? It is because of the best conditions that the area has for viewing into space. That's why we are putting our telescopes there. What are the conditions for us to see into space better? The conditions are these. We need dry air. Remember, the Northern Cape is a semi-desert. Okay, it's a semi-desert. Rains are scarce there. Okay, therefore, the air is dry, and most of the times the air is what? It is still. And then it is above sea level. And then what else? The conditions. The skies are dark at night. Why? Because they are not polluted by light. Remember, long back, the telescopes were near the cities, but we discovered that we don't see clearly. Why? Because the lights are polluting. They are disturbing the light that is coming in from space. Okay, therefore, we chose an area that will make us view from space better. Okay, if the skies are dark at night, there is no pollution of light, and the air is still, and there is no water vapor or humidity in the air, then there are no winds, then we view nicely from space. Okay, that's why all these satellites and the radio telescopes are situated in the Karoo. Radio telescopes receive radio waves in metal dishes. I think you have seen the metal dishes, grade 8. Even from home, you've got satellite dishes. Just go today when you reach home and check your satellite dish. All right, an array group of radio telescope work together because they are better than individual telescope. If we are talking about an array, we are talking about a lot of telescopes. If a telescope is working individually, then it's not going to give us the best quality. But if it's an array, it means there are many, they are working together, therefore we'll see a better quality. All right. And then South Africa has measured and has started building SKA. All right. And then good conditions for looking into space include clear skies. The skies should be clear. And then still air and little light or air pollution. South Africa has many places that have these good conditions. And then we are saying the good conditions are in areas that are semi-desert, like the Northern Cape. This is the best place to put these telescopes. All right. Remember, we said we've got what? We've got our SALT there, and we have our Hubble telescope there. And then we also have the meerkat, and we've started building the what? The SKA there. Okay. Because of the conditions that are good in the Northern Cape. To be specific, it is the Karoo. Okay. The Karoo is the main center for South Africa astronomy. Okay. And then let's check our WhatsApp questions. Remember, you need to send questions on 064 748 8913. Send us questions on 064 748 8913. Don't make a voice call, just text. Okay, we'll be able to check what you have sent. Let's check the questions. All right, it seems you didn't send any question on WhatsApp. So what we are going to do, we are going to carry on with our lesson, and we are going to take a short break right now. To look at our summary again and then make sure that you understand. If you don't understand, make sure you ask. Okay, our number again is 064 748 8913. Telescopes allow people to see much more detail in the sky. Why are we saying telescope allow people to see much detail in the sky? It is because of the lenses. Right, these lenses are bringing things closer, okay, and they are making images to appear clear and bigger. Telescopes gather light from an image of a distant body and they magnify the image. If we're saying they magnify the image, they make the image appear to be huge. It will be big. All right. Therefore, it enables us to study the bodies in the space. Okay. Therefore, telescopes are very important in our studies. And then optical telescopes they use lenses or even mirrors. They focus the light by refracting lenses or even reflecting mirrors. Did you understand when we're talking about refraction and reflection? If we're talking about refraction, this is the bending of light. This is refraction. Okay. And then if white light strikes the lens, that is the glass, it will refract. That is, it will bend. Okay. And then we've got reflection. If white light strikes a mirror or a reflective surface, what's going to happen? The light is going to be reflected to our eyes. Then we'll be able to see what we are seeing. That's what we mean by reflection and refraction. You understand that? That's very good. And then well-known optical telescopes are sold in the Hubble Space Telescope. And then the radio telescope receives radio waves in metal dishes. All right. And then in our country, the Karoo in the Northern Cape is the best place to erect our telescopes. Okay. Why? Because of the good conditions in the clear skies. All right. That's very good. And then we've got a homework activity. Question number 1, let's write the homework activity together. How far away from the sun is F? Number 2, how long does light take to travel from the sun to the Earth? 3, if the sun were to turn off now, how long will it take before the Earth is in complete darkness? Make sure you go and answer the questions on your own, research and answer and bring them to class. And then after this lesson, make sure you press the button, complete and continue, so that we'll see whether you've completed the lesson or not. Thank you very much, grade 8. Hope you have enjoyed the lesson as I have done. Make sure you always keep social distance, you sanitize, you wear your mask, and be kind to one another. So long for now.